Good afternoon, everyone. Now, after a short lunch break, I would again like to invite Saurabh sir to continue his session. Sir, please.
Thank you, Pratik. Okay, so shall we wait for a couple of minutes before some more participants can join in, or we can start? We can start. Okay. So welcome back to the second session of 24th December. We are having this FDP on 5G and 6G. So let's gather from where we left just before the lunch. So what we were discussing was about the spectrum challenge, why we require spectrum and what is the challenge in meeting those requirements. So that we call that as spectrum challenge. So spectrum, as we discussed, at its scarce resource, and there has been a lot of work which has been done to enhance what is known as spectrum efficiency or bandwidth efficiency. So you have like around the cellular communication as the end game is to enhance the bandwidth efficiency or spectrum efficiency. So next we will move to the second topic over here, that is cognitive radio spectrum sensing. So till now, if you have any doubts or any questions, you can please go ahead and ask and discuss, and try to be more, let's have more of participation rather than one-way communication. So it can be more of two-way communication or duplex communication. So this particular slide kind of reiterates what we discussed in the previous session, that spectrum is a valuable resource and there is a limitation and scarcity around it. So the other technologies like millimeter wave or say massive MIMO will not be able to, in isolation, like if they work in isolation, will not be able to meet the requirements of 5G or 6G networks. And we require the support of bandwidth spectrum access, or that is, in other words, more efficient use of spectrum. So we'll come to what is meant by more efficient use of spectrum. So that's where we say like there is still room for improvement. So how does this, what is meant by this term when we say that there is still room for improvement? Now, if we go to the frequency spectrum, electromagnetic frequency spectrum, then there are different bands. Some are known as licensed band, others are known as unlicensed band. So what is the difference between licensed and unlicensed band is that the licensed band is under some regulation, and if you want to use it, you have to get the nod or necessary approvals from the regulatory bodies around that. So for different geographical regions, we have different regulatory bodies which govern the spectrum. So that spectrum comes at a price and it's not free. Unlike the ISM band, like we have around the Wi-Fi that is 2.4 or 5 gigahertz, which is kind of free band, free Wi-Fi band, and you can use it freely without any license. So that is the example of unlicensed band. Now in the licensed band, there are some bands which we say as underutilized. So what is underutilized is that, now suppose there is a space, or like you have some highway, you build a very huge highway, and if it's not getting utilized or there is not appropriate number of vehicles which are using that, so we can say that this particular highway is not getting utilized. So in a similar sense, there are certain bands or certain channels which are not utilized to their potential. For example, the TV space, television channels. So they are using around 600 megahertz to 800 megahertz, that is the frequency band, and there are a lot of white spaces around that. So what is meant by this white spaces is that those channels are not occupied, or those channels are not properly utilized. So we need to use that particular white space, because that is the potential. Because if you go to the band around, say, cellular, which is 980 to 1000 megahertz, or around 2 gigahertz, or around 6 to 12 gigahertz, so all that band is quite, you can say, it is already very much utilized. So there is not much room, there is room but not much room for improvement. So first is utilization of the white spaces. White spaces means those bands which are not getting properly utilized. So we need to incorporate those bands into the 5G communication. That is utilization of white spaces for the TV channels. So here this is, like, according to some research, that the television broadcasting have unutilized frequency portions which can be known as white spaces which can be utilized. So that is the essence of cognitive radio. So like cognitive radio is recognition. First is cognition. It comes from cognition. Cognition means recognition or sensing. So sensing the available spectrum. So first step is you have to sense the available spectrum. Just like, for example, if you're using a Google map. So Google map, using a Google map, you can see what is the way, what is the route to go across in case there is a traffic jam. So Google map, using its algorithms or its intelligence, can suggest that this is the appropriate route to go ahead in case there is an alternate route to go ahead. So similarly, what we are trying to do, we are trying to orchestrate an alternative frequency band through which a network can get free of any congestion. So that is at the heart of what is the concept of cognitive radio. So cognitive radio is making the spectrum access more efficient through planning and through prediction. So this prediction can be done in two ways. First way is the conventional method where we use narrow band and wide band spectrum sensing. And the second is more, you can say, it is based on predictive algorithm, so that you can sense that which particular band, based on the previous pattern, which particular band will be free in the next instant of time. So that is what is predictive spectrum sensing. So here the core or the gist of this presentation is around predictive spectrum sensing. So what is the difference? Before you are struck in a jam or before the network gets congested, before the congestion or before the event happens, you should be able to, or the network should be able to jump to a non-congested channel. So that is the essence here. It's not that you wait for an event to happen. You wait for congestion to clog your network. No. You have to make a proactive decision. So this is more of a proactive technology where you can use the prediction algorithms to decongest or in other words, not decongest, to avoid any congestion. This is more of avoidance rather than cure. So this is prevention rather than cure. Just like suppose you go to a doctor. When do you go to a doctor? After some malady is there, after some illness strikes. How many of us go to a doctor to prevent that illness? So that is the gist here. Going to or taking the remedial step even before it strikes. So that is here. So before we can reach that stage of say set some threshold that if the networks or the channels are getting congested, then we ought to jump to the next predictive channel or wherever we can sense that this channel will be free. So are you aware of cognitive radio technology? How many of you must have gone through cognitive radio and what is this primary user and secondary user? What is the difference between primary and secondary user in cognitive radio?
Licensed and unlicensed users.
Yes, licensed and unlicensed. In a sense that these primary users can also be known as priority users. Like the priority users, they will be given the priority. And however, what is happening is, suppose I am speaking to you. During a total span of 1 hour, how many minutes I have spoken? Although I'm supposed to speak continuously, but out of those 60 minutes, how many minutes does a normal speaker speak? Yeah, so that is known as what is voice activity detection factor. So even if you are a politician or even like a very proficient speaker, so the voice activity detection factor of a human is not more than 40, like say 60% or 70%. There will be intermittent spans where there is a pause. So when there is a pause, that means that particular channel is not being utilized. Or in other words, that channel is free. So first is based on the voice activity detection factor of a user, you can predict when that particular channel will be free for the secondary user. Because who is secondary user? Who is secondary user? Secondary user, as you said, like unlicensed or non-priority users. Like they are not given the priority, but they are kind of opportunistic users. They seize any opportunity where they get a free channel and then they will utilize that channel. So secondary users are opportunistic users, whereas primary users are priority users. They will always get the priority, just like you have a difference between tenant and a landlord. Now suppose you are staying as a tenant. but the landlord says, okay, I have to come and stay here, so you have to vacate the house. So similarly, a secondary user is like a polycystic user who can stay on the channel, can use the channel, but will have to vacate the channel when the priority user comes. So this is, however, to support, but the primary user is not using the channel at all times. The voice activity detection factor is there, and it says that maybe it's only 40% or 50% of the time that the channel is getting used. So 50% utilization is to be done. So to optimize the channel efficiency, to optimize the spectrum efficiency, we have to make use of this 50% free white space. Now, this is the concept. Second phase comes the implementation. You understand what is the basic concept? Concept is voice activity detection factor. We have to utilize the channels which are free. The implementation comprises of essentially two steps. First is sensing. Sensing the spectrum when that spectrum will be free. And once you sense it, you allocate that spectrum. So this sensing and allocation of spectrum needs to be done dynamically, needs to be done in an automated manner using the prediction algorithms. So that is again, for that you have to develop the algorithms which can sense the channel and which can allocate the channel. And when not only allocate, they should also be able to deallocate the channel if the priority user comes back. So this is the concept, and this is next phase is the implementation of this concept. Yeah, so primary users license, they have high priorities, consistently we can access on a non-interfering basis on regulatory authorities. Okay. That is the difference between primary and secondary users. Now we come to the phases of cognitive training. So this is the cognitive cycle, and as you can see here, analysis of spectrum, like how much spectrum is kind of free, how many white spaces are available in the spectrum. Then comes the spectrum sensing. Spectrum sensing comprises of finding out what is the, say, usage pattern of the primary users or the priority users, and then second is, once you find out, you can allocation and management of spectrum means you can assign to secondary user, you can allocate or deallocate. So three phases of the analysis: analysis of spectrum, spectrum sensing, allocation, and management. Any questions on this? Any doubts? You have any? What is the difference between primary and secondary users? Because the concept is there and the implementation. So these steps will comprise of like obtaining information from the environment, adjusting them dynamically, learning from experience. So as soon as this term comes, learning from experience, what rings it should ring a bell. What is that bell? Yes, it is. Past experience means you can use machine learning algorithms. So in machine learning, you know that you utilize the past data or the past patterns to design or predict the new usage pattern. What is the new usage pattern based on the previous pattern? Obviously, you should be having a large sample size to create a model. So this is spectrum sensing, decision sharing, and mobility. So around this, you need to have a dynamic process. You need to have it reconfigurable. You should be having an automated system. That the network should be able to sense the spectrum, should be able to dynamically allocate and deallocate the spectrum. So this is again analysis of spectrum. Okay, now we will slightly focus on traditional spectrum sensing techniques. So there are essentially two conventional spectrum sensing techniques. One is the narrow band, one is the wide band. So what is meant by narrow band and wide band spectrum sensing? Anyone? For what is narrow band, like narrow band communication or wide band communication? What is the difference between narrow band and wide band? Like if you say, like example of say GSM, Global System for Mobile Communication, which is 2.5G or 2G. So this is an example of narrow band. On the other hand, if you come to say CDMA or 3G communication standards, they are example of wide band. So how do you say that this is narrow band, the other is wide band? Or even like you say, do you have like in internet connection, you say broadband communication, you have broadband. What is this broadband? What is wide band? What is narrow band? So to decide whether it is broadband, wide band, or narrow band, we have to focus or learn upon a concept which is known as coherence bandwidth. So whenever you have like in cellular communication, we should be clear about the concept of coherence bandwidth and coherence time. So what is coherence bandwidth? So you know that bandwidth is the inverse of time. Similarly, time, coherence time will be the inverse of bandwidth. So when you define coherence bandwidth, it is kind of defined if you like have from Rappaport or other texts who have defined coherence bandwidth. So they want to describe coherence bandwidth as the reciprocal of the time. So it will be 1 upon second or microsecond, whatever it is. So that you get the bandwidth in hertz. So it is the reciprocal of that time in which two successive symbols do not overlap. The time between two successive symbols do not overlap. So what is, like again, to understand this is the basic concept of wireless is, what is that? Multipath propagation. Because wireless is not a bound channel. It's not like it's going through a wire or a bound channel. It is completely unbound channel. It can take various multiple paths through reflections, multiple reflections. So coherence time or coherence bandwidth is the reciprocal of the time which is required to avoid any intersymbol interference. So the coherence bandwidth, if you are sensing that the spectrum which is larger than this coherence bandwidth, then it is wideband spectrum sensing. If you are sensing a narrower bandwidth which is less than this coherence bandwidth, then you are sensing as known as narrowband spectrum sensing. So that's what it's mentioned, like only a small portion of that spectrum is sensed and it is smaller than the coherence bandwidth. To understand this, you should be clear what is coherence bandwidth. And coherence bandwidth, to understand, you should have that multi-path propagation effect. Because wireless is characterized by multi-path propagation as an unbound channel. It's not a bound channel. That is why security is also a challenge in wireless. It is always advisable not to do any financial transaction if you are on a Wi-Fi network. Because Wi-Fi is what? It is unbound channel. Even if you are using in a home network, but you do not know how many rogue users may be accessing that SSID. In fact, when you get that SSID and the default password, first thing you should do is to change the SSID and the default password. Nowadays, companies have started mandatorily like removing the default password so that the user who is using has to set his or her own password. So avoid doing any sensitive transaction on a Wi-Fi network, and especially never on a public Wi-Fi. So, unlike a wired channel, wireless has its own security challenges because why? It is unbound channel. So that is again a different, completely like whole topic around the security protocols we have around wireless channels. Because not only wireless, like wireless is less secure, but at the same time, it is also power intensive, power challenging, because the resource may be only a mobile phone, like that it has limited power to do this or use the protocols. So now the battery may fade away if you're using intensive protocols. So again, what comes into play? Energy efficiency. What is energy efficiency? What is spectrum efficiency? So that's why I say, like in wireless, the end game, whether it is 1G to 6G, end game has to be around energy efficiency, around spectrum efficiency and energy efficiency. Although there will be definitely a trade-off between them, between spectrum efficiency and energy efficiency. So that is these two kind of spectrum sensing where we can have narrowband as well as wideband. So now I need like any questions around what is wideband, what is narrowband spectrum. What is narrowband? It is simply the band, or if we select a particular band which is less than the coherence bandwidth, then it will be known as narrowband. On the other hand, if we select a wider band which is more than or which is larger than the coherence bandwidth, then it is known as wideband. So now we come to the same concept. We said proactive and reactive. Like proactive is the same as you take precautionary measures, like you kind of go and prevent an event to happen, prevent an adverse incident, or prevent an adverse event. So what is adverse event in wireless? Congestion in network or network failure. So you have to prevent that. Not when there is congestion, then you react. That is a reactive method. But you have to take proactive method. So in a reactive method or in a proactive method, you have to do some allocation and management of spectrum using the available techniques, or you can use the predictive techniques, or you can also develop a model, or you can use a kind of a. So what we are trying to do, we are trying to blend the conventional technique with the predictive technique and trying to create a model. What is that model? Model will be for spectrum sensing and allocation. So these concepts are again around dynamic spectrum access, we have already discussed. Okay, before I go on to the machine learning algorithms, I just want to spend some time on this slide, cognitive radio and carrier aggregation. What is the possible or correlation between these two, cognitive radio and carrier aggregation? Is there any guess for that? Like, what is the, why are we saying like cognitive radio and carrier aggregation? What is the relation between them? What is carrier aggregation? Like suppose you have a particular channel, or you have a bandwidth of, say, you are having a total bandwidth of 1000 megahertz. Then you want to break it down into channels, and you break it down into 5 channels of 200 megahertz each. So how many sub channels you have? 5. 200 megahertz, and you say that every user can be using that same bandwidth of 200 megahertz. However, one user who may be using some live video stream has a higher bandwidth requirement than the other user who may be simply using it for some non-critical application, non-time critical application. So what can be the possible solution? The possible solution is carrier aggregation. Carrier aggregation is like instead of having, suppose on a highway there are 3 lanes. Now if there is a large vehicle which may require more space, so what can be done is 2 lanes can be combined together so that that vehicle can move. So instead of 3 lanes, we make it 2 lanes, and like out of those 3 lanes, 2 lanes are allocated to that heavy vehicle, and the rest vehicles can move in the other lane. So that is like that is the concept of carrier aggregation. So what we are doing, we are kind of bundling the pipes. So if you combine more than one channel together to make a larger channel, so that is known as carrier aggregation. So again, cognitive can also play a role, like when you are sensing the spectrum, it can also play a role in carrier aggregation. So this is another important concept of carrier aggregation, how you can enhance the bandwidth. So that's what through concurrent usage of radio resource. Concurrent means you combine simultaneous channels. And you can extend up to, however, like suppose you have 5 channels only, you can aggregate all 5 channels together to make it a large bandwidth or wideband spectrum. So these are the various elements we have in the cognitive terminal, or how you orchestrate a cognitive radio system, cognitive terminal. So like geolocator, software-defined radio, learning system, policy, optimization, and sensors. So like sensors will be used to sense the spectrum. Geolocator, like the location of the users. Software-defined radio will be used for the allocation and deallocation of spectrum. Learning system to learn the pattern so that you can develop your algorithms. Policy database will be for the policy for priority and secondary or polygistic users. That is the policy. And finally, you have some kind of optimization. Once you have the learning and the policy, then you can use the optimization algorithm. So these are the various elements of cognitive engine. You call this as cognitive engine. So again, these are like a definition what I just described. You can obviously go through the slides and get through it. However, there are some challenges within the cognitive engine, like you have to obviously, as you can see, it suffers like high complexity because of high number of computation. So there are a lot of challenges around the cognitive engine. So to combat that kind of complexity, to reduce the complexity, what is, we can choose some alternative method, and that alternative method can be your prediction algorithm. So instead of using the first method was for spectrum sensing, we saw there is a complete cognitive system or cognitive engine, but it suffers through high level of complexity and higher computation. It also needs privacy, security, and other like large amount of power. So these are some of the challenges in implementing cognitive system. So instead of that, we can also go towards prediction algorithms. And in the prediction algorithms, let's see what are the methods available. So these are the two, you can say, the prerequisites for designing the prediction algorithms. So these are the prerequisites, like to prevent, like what is the learning process. We said that there should be a learning process, and then this network should have sufficient intelligence to learn from past events, so that we can make it a more of an adaptive, more of a dynamic environment. So self-reconfigurable is something which we discussed, privacy and security. Okay, so now finally we come to the spectrum sensing techniques. As we can say, like this is narrow band and wide band. So we discussed this, what is spectrum sensing in the traditional method. Now let's move to predictive spectrum sensing. So this slide kind of explains the process, that what is predictive spectrum sensing. It's kind of informed and advanced decision to predict when your particular spectrum will be, say, free, or when you can utilize the white spaces. So this decision has to be made by the secondary user or the opportunistic user, when they can go and kind of grab the channel which is available for the primary users. And they can also, but at the same time, there is a catch that they have to vacate the channel for the primary users or the priority users whenever they are. So this allocation and deallocation has to be done from the end of secondary users. Now these are some of the advantages of predictive spectrum sensing. Reduced sensing latency. So what is meant by reduced sensing latency? That the amount of time required for sensing is reduced. That is, sensing latency is reduced. Because this whole hopping from one channel to other channel, or this has to be done in the order of milliseconds. So we should have minimum latency as far as possible. And then obviously it has a proactive and real time. So proactive is something where we prevent any network congestion. So these are the machine learning algorithms which are available. Out of them, like we will be using, so we have studied, these are the particular algorithms which has been studied by my research group or the students. So instead of like going for the supervised or unsupervised, we will stick to reinforcement or reinforcement learning or reinforcement neural networks, RNN. So these are the key models, say hidden Markov model, artificial neural networks, and the deep learning models, which will be which have been studied, and obviously a strong contender will be artificial neural networks for this, where we can say optimize the whole process of sensing. So this is about what is hidden Markov model and neural networks, which will be having the training phase and prediction phase. Then deep learning model, but deep learning models are efficient, but then they can be computationally intensive as well as they can be complex in nature. So you have to weigh the pros and the cons, like for before you decide. So deep learning model and neural networks can be strong contenders for them, and especially we will be working on the concept of MLP. So we've kind of narrowed down to have multi-layer perception. What is multi-layer perception? This is a concept in neural networks where we have, in say neural network comprises of various layers. So where you have each layer will comprise of neurons. So in multi-layer perception, each layer or each say node in a layer will be connected to all the nodes in the successive layer. So that is multi-layer perception. So multi-layer perception will be utilized in defining the reinforced neural networks, RNN combined with MLP. So that is kind of, I would say, not much work has been done, and so we're trying to develop this work or this whole algorithm around this one, that is RNN combined with multi-layer perception. So it is a kind of a neural network model which we are trying to build for whole process of sensing and management of spectrum. So just to recap, when we started with what is the requirement for say 5G or 6G, and what is the role of spectrum. Then for spectrum, we kind of discussed about spectrum utilization, enhancing the spectrum efficiencies, enhancing the spectrum or bandwidth efficiency and energy efficiency. Then we come to like what is spectrum efficiency and what are the means to enhance that. So the work which is going on is basically to devise a predictive method or a particular algorithm which can dynamically sense the spectrum and allocate the spectrum in a more efficient manner as compared to the traditional existing prediction or existing methodologies which are being used for, which have been used for predicting or sensing the spectrum. So that is the gist of the work. So currently, as I told, we are still in the development phase. We do not have the results to compare with other algorithms, but this is the, say, concept behind it. Okay, so this is more of a theoretical, so I won't go to each of the slides. I would rather suggest, if you want, you can go through the slides. If you have questions, you can always email. If obviously this is a topic of more of a specific research. So this is meant for students from UG or PG who want to pursue some research. So any student who is interested can go ahead and discuss with us. However, this is the end game is around again spectrum efficiency, enhanced data rates. High returns means for the user. Okay, thanks. It's all right. We have already ended. It's all right. So this is the gist, like end game, spectrum efficiency, enhanced data rates, high returns means high returns for the service provider because you are utilizing the spectrum in a more efficient manner, and obviously it will also result in energy efficiency. So these are the end goals for the entire, like say, wireless industry, because when you are designing a technology, so technology is the means to achieve those goals. And technology, as I said, are kind of a leading indicator of the standards. So when you say like, okay, you are in 5G or 6G, so it has to be a paradigm shift in the technologies which are getting used. Okay, next is that was about the communication or about the presentation around 5G and 6G. Now, if you have any questions or if you want to discuss anything about the academics or industry landscape or the divide, or if you have any questions, you can go ahead. Anything regarding the topics we discussed, or anything if you want to discuss about the preparing for industry, or any questions regarding the industry trends. Okay, I think there are no questions. Yeah, thank you.
Rajya sir.
Now, moving towards the end of our today's session, I would like to extend our sincere appreciation to Dr. Saurabh Dixit sir for his exemplary leadership at the session chair. Now, as a token of gratitude, we are pleased to present this certificate and shawl symbolizing our deep respect and thanks for your invaluable contribution. Sir, please. Thank you, Dr. Dixit, for enriching this session with your insights and commitment to excellence. Thank you, sir. Thank you, everyone.